Number 24 says, let f be the number of trees in a forest at time t in years. If f is decreasing at a rate given by the equation df dt equals negative 2f, and if f of 0 equals 5,000, then what is f of t? To solve this, we need to separate the variables. We need to bring our f's to one side and our t's to the other side. To execute this technique, I'm going to just start by rewriting the original equation and then bring all the terms that have f to one side and t to the other side. So I'll divide both sides by f to get df divided by f, or df times f to the negative 1. And on the right-hand side, multiply dt to get negative 2 dt. Now let's integrate both sides of this equation. The left-hand side will be integrated with respect to f, and the right-hand side will be integrated with respect to t. The antiderivative of 1 over f will be the natural log of the absolute value of f, and there should be a plus c here, but I'm going to implicitly combine it with the plus c that we'll get on the right-hand side. You can just subtract that constant and combine it with the constant that we get over on the right-hand side and just write it as a single constant. So the antiderivative of negative 2 will be negative 2t, and this is where I'll include that plus c. Now I need to get rid of that natural log, and to do that, I can exponentiate both sides of this equation using Euler's number as the base. So if I raise Euler's number to the natural log of the absolute value of f, that just gives me the absolute value of f. And if I do the same thing on the right, nothing is really going to simplify here. I'm just going to have Euler's number to the negative 2t plus c. Now, one thing we can do here is notice that we have an exponential function on the right-hand side. That is going to be positive, so we can drop the absolute value symbols and just be left with f equals. And then one other thing that we can do here to simplify this equation is to rewrite this e to the power of negative 2t plus c as e to the negative 2t times e to the c. We can do that because of our exponent property that says if you've got two powers with the same base and you want to multiply those two powers together, you simply can add those exponents. And we're using that property backwards here. And one reason for doing that is that e to the c to the some constant power is still going to be a constant. If I raise a constant to another constant power, that's just going to be some other constant. I'm just going to rewrite e to the c as c, knowing that it's just some constant. So I'm going to rewrite this equation as f equals c times e to the negative 2t. Now we have our equation for f, but we need to find what that c value is. And to find that, we're going to use the initial condition that f of 0 is 5,000. So if f of 0 is 5,000, then at least in this case, f would be 5,000. C is what we're trying to solve for. And then we have e to the negative 2 times 0, with t being 0. Now, negative 2 times 0 is 0, and e to the 0th power is 1, so that means that 5,000 must be c. So now we have our final equation for f, which is 5,000 times e to the negative 2t, and so our answer is B.